Within the engine bay, we also find a 12-volt lead-acid car battery. This stores energy in the form of chemical energy. It does not store electricity.
Generator that converts mechanical energy to electrical energy in the form of alternating current. Electricity is produced in alternators by electromagnetic induction. There are two types to produce electricity in alternators.
We find the alternator within the engine bay of the car. The shaft of the alternator is connected to the engine via a belt and pulley. When the engine is running, the shaft of the alternator is forced to rotate. This rotation generates electricity. An alternator looks something like this. The alternator produces a type of electricity known as AC, or alternating current, and this is why the unit is called an alternator.
There are two types to produce electricity in alternators. Type 1, rotating magnetic field with a stationary armature. Type 2, a rotating armature with a stationary magnetic field. Most alternators use a rotating magnetic field with a stationary armature. Main parts of the alternator are rotor, stator, outer cover, pulley, regulator, bearing, slip rings and DC generator.
When the engine is off, the battery powers the car's electrical components. This will drain the battery though. When the car starts, the battery provides a huge amount of current to the starter motor, which turns the flywheel and starts the engine. The battery is again partly drained during the startup because of the large current required to turn the starter motor. Once the engine is running, the alternator is used to recharge the battery so that it has enough stored energy to start the engine again in future. The alternator will also power the car's electrical devices while the engine is running. But if the battery is left to discharge for too long, then it will not be able to provide the large current necessary to start the starter motor, and so the car will need to be jump-started. There are many different designs, but this is an example of a simple 3-wire design with an internal regulator and rectifier which has the following terminals. First of all, there's the B terminal. This is the output of the alternator which charges the battery. Then we have the S terminal. This allows the regulator to sense the voltage. And then we have the F terminal. This is connected to the ignition and provides the initial power to the electromagnet during startup. To complete the circuit, electricity flows back through the car's frame to and from the battery's negative terminal. As this unit has an internal regulator and rectifier, we find these components at the rear end of the unit, which is usually under a protective cover. By removing the housing, we can see inside the unit. The first thing we see is the stator. The stator is stationary and does not rotate. This consists of a number of laminated sheets which have a pattern of slots around the inner edge. Then we find 3 separate sets of copper wires which are wound between these slots in a certain order. One end of each coil is connected together to form a neutral point. This is a star configuration. Each coil set will produce a single phase of AC electricity, providing 3 phases in total. The other end of each coil passes through the case and attaches to the rectifier. The alternator produces AC alternating current, but the battery and the electrical devices of the car need direct current. So the rectifier is going to convert the AC into DC electricity. At the center of the alternator, we find another coil of wire which is wound around an iron core and connected to the shaft. The shaft also holds 2 slip rings. The slip rings are connected to opposite ends of the coil. Within the rear housing, we find some brushes. These are some spring-loaded carbon blocks which are pushed outward to rub against the slip rings to form an electrical connection. The car battery initially provides electricity to the coil via the brushes. As the electricity passes through the coil, it generates an electromagnetic field. To enhance this electromagnetic field, 2 iron claws are placed either end of the coil, which will interlock with each other. One end will become the North Pole and the other will become the South Pole. As the electromagnet is attached to the rotor shaft, when the engine turns the shaft, it also rotates the electromagnet past the coils of the stator. this will cause the stator coils to generate a current, and so electricity is generated. Once the alternator is generating electricity, the alternator is able to power the electromagnet by itself via a diode trio, which converts the three-phase AC into DC. The voltage and current produced by the alternator will vary with the speed of the vehicle. The faster the vehicle travels, the faster the crankshaft rotates, and so the faster the alternator also rotates. This increases the voltage and current. To control this, another component is used called the regulator, which is mounted at the rear of the unit. This is an integrated circuit board which monitors the output of the alternator and varies the current flowing through the electromagnet to control its strength. The strength of the electromagnet can be used to vary the output from the alternator. That's why the alternator uses an electromagnet, so that it can control the output. The car battery powers the electromagnet, although most modern alternators will use a diode trio, which converts the alternating current of the alternator into direct current and powers the electromagnet via a voltage regulator once the alternator is generating electricity. On the power supply of the electromagnet within the regulator, we find a component known as a transistor. The voltage sensor is also connected to the regulator. The transistor is a type of electronic switch, which can be turned on and off thousands of times per second by a controller. This can be used to control the amount of current flowing. If we imagine that the current flowing through the coil from the battery is at its maximum level for a given period of time, then we get 100% current and the electromagnet is at 100% of its strength. If the car speeds up, then the magnet will spin faster and that will increase the output voltage and current. But if we now control the switch so that electricity is only flowing for half of the time, then we get 50% of the current and therefore the electromagnet is only 50% of its strength. So, by measuring the output of the alternator and then varying the open and close times of the transistor switch, we can control the current flow through the coil and the strength of the electromagnet. This controls how strong the electromagnet will be, which affects how much electricity is produced. This produced electricity charges the battery,